Thanks, Aaron. Good afternoon. Wow, there's a lot more people left than I thought there would be. I couldn't put you off then, no? Have you had a good conference? Yeah? Fantastic. Favorite talk, anyone? Shout out. This, oh, I know, all right, yeah, plants in the front row. What was that? This one, another this one. All right, you're all very, very kind. You haven't seen it yet. You can tell me afterwards if you think that's true. Game Boy, yes. Tom Tesh's, I only caught the end of that, unfortunately, because I was preparing for this, but I'm... Pattern matching. Yeah, we've had tons and tons of really interesting talks. I've had a great time. My favorite probably was Barry's on reflection, like an actual practical demonstration. Obviously, yeah, oh, there's a few claps as well. And Herb showing us kind of what's going to be coming as well. All those are sort of like the surprise for me was going to see one of the unrecorded ones that Pixar gave, and they led us into some all sorts of interesting things. But, you know, so if you're watching this at home on the YouTubes, you're not going to be able to see that one. You'll have to come next year to see the kind of quality content that they can't record. So, anyway, it's been a great conference. It's been absolutely fantastic. But I'm up on stage here, and you know what I'm like. I love to talk about assembly. That's my thing. And I kind of want to justify that. So if you'll bear with me a little bit, I want to kind of give you some idea why I'm so obsessed with this thing. Cast your mind back, 1986. In a room in the southwest of London, me and my sister, I'll let you work out who's who. Me and my sister are in the spare room at the back of the garage that had been converted. It was freezing cold because there was no insulation, but we had room for a computer and apparently some pound puppies, which I don't think made it over here, or maybe did they? Anyone? Yeah, okay, some people about my age are going, and you'll see that I'm working busily on a computer. That computer is a ZX Spectrum, which I'm sure a few people in this room know about. And I'm programming. And I'm learning already, even though I'm only 10-ish in this photo. It's the only photograph I could find of me, or I say I. It's the only photograph my dad could find of me and my computer of anywhere in this era of time. And how did I learn to program? Well, on this bookshelf, you can't really see it from where you are, but there's a rainbow-colored book. Some of you might even recognize this, certainly the British folks. This is a book called Over the Spectrum. Over the Spectrum contained type-in programs. Who here learned to program by typing in programs from like a reference? There's a lot of hands in here, and there are very grey people underneath them. Grey-haired, I'm sorry, not just grey. That's mean of me, isn't it? So I learned to program by typing in programs because you wanted to get a game, or you wanted to get some kind of tool, or a simple like application, and then you'd save it to cassette tape because that was the only thing we had back then. But often you'd type it in very, very wrong, and then you'd have to try and work out where all your typos were. And that was my first sort of introduction to the wonderful art of debugging. Now, these games were written in BASIC for the most part, but as they got more and more sophisticated, BASIC wouldn't cut it anymore, and so you started typing in assembly. And that's where I learned what assembly was and how important it was and what you could do with it. Now, I've got a quick admission to make, actually, before I get too far away. Now, the astute among you may say, that doesn't look like a programming session going on that TV screen, and it is a TV screen. So yeah, it isn't. I zoomed in. I remember this TV so fondly. And I thought that looks like a game, but I couldn't place it. And so what do you do when you find some weird image on the internet or anywhere and you want to find out what it is? ChatGPT, is that what I'm hearing? Yeah. So I put it into all of the various AIs, and they all drew a blank. So AIs are not infallible. Well, sorry, is that? Oh, right, okay. I didn't quite catch that. So AI doesn't solve all the problems of the world. I think we've discovered some of that at this conference. I posted this in a Spectrum enthusiast channel on Discord. 30 seconds later, I got this image back saying, oh, it's Mugsy. So, you know, AIs are fantastic, but you can't beat somebody at their keyboard trying to prove you right or wrong. I actually remember this game quite well. This was it's like a gangster management game. You would like allocate funds to bribing police and paying off people and beating up whatever. And oh no, it didn't load. Hang on. If all had gone well, this image here that you're now looking at that's a very sad thing. The address could not be found. This does not bode very, very well. Let me reload the slides. Please cross your fingers for me. There we are. So earlier this year, I actually took it upon myself to write. This is a complete aside. This has got nothing to do with anything. I'm just showing off. This slide here shows that a Spectrum emulator that I wrote in C++ and compiled to WebAssembly, and if we're good enough, we can actually play my game in my slides, which is a fun thing to be able to do. So, C++ is the future of web development. I think you'll agree. Later on, I moved off from the books that I had, and I would buy magazines and type in the programs from magazines. For the younger amongst us, a magazine is like a sequence of blog posts that have been printed out and would be in the newsagent once a week or once a month. Sorry, I've got to get a few age jokes in. This was Acorn User Magazine, and again, one or two of you in this room will know what this magazine is. It's for an obscure British computer called the BBC Micro, and later the Archimedes. And by this time in my life, I was about 14 or 15, I was sending in programs to magazines instead. So this was actually my program, and I think Jason earlier today said that the very first time that he said my name out loud in a conference, he misspelt it or misspoke it. This has haunted me kind of most of my life. I'm Godbolt there apparently, but that is me, and still my best friend, Rich DW. So by this point, we were sending in programs and getting £50 every program, which is a lot of money, even split two ways when you're in 1994 and you're 15. A lot of games you can buy. These programs were all in assembly, and you would be seeing it now if my clicker was, there we are. So there's probably about 20 pages of tiny font, which you can't read, I'm not expecting you to read, in the magazine that some poor people would actually sit and type in. Now, if you were very posh, you could buy the floppy disk that came with it and save yourself all the bother. But this is where I cut my teeth. These were the first sort of commercial programs I ever write, and they were all in pure assembly, which is pretty painful, right? A bit later on, I discovered the internet, as we all did, which is, some of us may now think is a bit of a mistake, but by and large, it's doing okay, right? Who here remembers Internet Relay Chat? Oh gosh, that is a lot of hands. Wow. For the recording, that was about 3/4 of the audience. So IRC was kind of Discord-ish before Discord, except it was federated, and you had to have a special client program that would talk to it. There wasn't a special client program for it for my weird computer. So by this time, I'd moved on to the Archimedes, which used this ARM processor, this new ARM processor that you may have heard of a few times since. The company that developed the ARM processor, coincidentally, was the company behind those computers, both the BBC and the Archimedes, and they went sort of bust, but the IP and the rest of the company that does all of the chips are kind of now ubiquitous. But they have their one foot in Cambridge in the UK. So by this time, I decided I wanted to write an IRC client, and so I did. And this is what it looked like. This is the one and only screenshot I could find in existence, so thanks to my friend Jerf, who still had a picture of it somewhere. It's fully windowed. It has to talk TCP. It has to parse and send messages and format complicated strings. It has to allow you to do direct client-to-client communications to send files between each other. It lets you do, there's a scripting language built into this. So I came up with my own sort of basic inspired scripting language, and I gave it dynamic allocation, and I thought, hey, there must be I could use reference counting. So I implemented reference counting, and then I discovered that there's a problem with reference counting, the one where you have cycles. So I came up with this whole idea where I could find the things that were no longer referenced and delete them myself. And then many years later, I spoke to a friend who said, oh, you invented Mark Sweep garbage collection. And I'm like, I suppose I did. Oh, I was doing a physics degree by this point. I had no idea about computers. But this program and everything in it, 100% assembly. There's just nothing else. It's just pages and pages and pages. All these are in GitHub if you want to go and have a laugh at the ludicrous names of labels and things that, when you have to give a name to everything, you start losing the meaning between anything at all. There's like also, oh, this one's got some good names in it, actually. No, my favorite one in this is Womble Loop Jedi. I have no idea what it meant. So anyway, assembly was kind of coming along with me for the ride by this point, and I was used to seeing it everywhere. That changed when I decided that I wanted to run a multi-user dungeon. I'm sure, again, some hands up here have played a multi-user dungeon along the way. It's sort of like Dungeons and Dragons in text mode, multiplayer. So you can connect into it, you can group up with friends, you can go and kill monsters, cast spells, all that good stuff. I couldn't write a whole multi-user dungeon by myself, but we found some source code knocking around on the internet, and the licenses were okay. This was before, GitHub, before anything like that. There were sort of tarbles shared, usually on IRC, between people of source code. And this source code was in a programming language called C, and it was actually pre-KNRC, so it was all the horrible format without, yes, everyone's shaking their heads going, oh gosh. And so this is what I learned. I had to learn it. If I wanted to write a game, like a MUD, I wanted to learn C. And by this point, I was at university. We were running this MUD when we shouldn't be running the MUD. We weren't allowed to run long-lived processes, but we found ways. But what that also meant is that the administration would find us from time to time and shut down our account, and then we would have to find a new computer, which would often be a different operating system and a different architecture. And so at this point, I learned the benefit of that being written in C, because rewriting it all in assembly would just not have cut it. Towards the end of my time on Xeniamug, we found some source code in C++, which was this newfangled thing that was coming along. And we integrated it into the MUD, and it was like an early LLM style, well, more like Markov chain ELIZA bot, so you could talk to the other NPCs, and they would come back with somewhat interesting things. But that opened my eyes to the fact that C wasn't just a jumped-up macro assembler, which is what I thought it was before then. It could be so much more. I got a job in the games industry, and pretty much everything in the games industry is C or C++, or variants therein. Croc here is entirely C, if I remember, and then the other ones here are mostly C++. And so you might think I'd left assembly behind by this point. But no. Compilers were not very good back in the 90s and early aughts. Many of the instructions that the CPUs had some very specific games-oriented extra instructions that the compilers didn't know about. And so if you wanted to take advantage of those things, you had to write in assembly. So this is from Red Dog Superior Firepower, which is an excellent Dreamcast game that you should all rush out and buy, although it's perhaps a little late. And you can see that my assembly code has gotten a little bit better. It's certainly better commented. And then obviously, this happened to me. And that's why I'm standing on stage in front of you all. I've told the origin story a number of times before, but I'll do it one last time here, because I was basically arguing at work. I'd moved on by this point to finance, and so I was working in trading, and my boss at the time said, well, we can't use this new C++ feature. We don't know if it's fast or not. And I'm like, well, we could benchmark it. And we looked at the benchmarks, but they were sort of ambivalent. And, and him being very conservative was like, let's just leave it alone. So we were debating whether we could use a range-based for instead of just for in I equals 0, I is less than size of array. And in fairness, we had just been bitten by another programming language where that wasn't actually equivalent, and it did, in fact, slow things down. So he was a bit sensitive. Anyway, I knocked up a quick shell script, and we toggled backwards and forwards and had a Unix terminal just kind of continuously show the assembly output, and I thought, well, this is messy, and I sort of grep -v'd out some things and set it and piped it through C++ fill, and I'm like, oh, this is cool. I can edit the code over here in Vim, and on the right-hand side, I get the assembly keep popping out. There's something to this. And Compiler Explorer was born. And so what I really want you to go home with today is the idea that even though in C++ we tend to aim for higher abstractions, assembly is still super important for the language, and for us. And I know what you're thinking. I know that I've said this before on stage, and I've talked about it again, but I'm just going to go over a few bits and pieces, and I think that there's some interesting stuff that we'll discover along the way. So, I keep saying this word. What does it mean? So I went to the Wiktionary, and I said, what is assembly? And it says, it's a set of pieces that work together. It's the act or process of putting together a set of pieces. It's a congregation of people in one place for a purpose. It's a legislative body with the ominous politics. Military, a drumbeat signal for troops to assemble. And then finally, the one that we care about, it's the ellipsis of assembly language. So when I say assembly, I've been saying it wrong. I've been misspeaking. I should be saying assembly language. That's what I'm talking about. So let's talk about assembly language. Many of you might consider assembly language very much like the inscription on this ring. It's sort of impossible to read, shouldn't be spoken out loud, and a dark cloud comes over you every time it gets close to you. But I really don't think of it that way. And I'd like to think that Compiler Explorer over the years has introduced enough assembly for you to get over the hump of being scared about it. I think of assembly like Shakespearean poetry, like a sonnet, or a sonnet, sorry, forgetting my similes here. That is, it's a beautiful piece of text. You can kind of squint your eyes as you read it, and you get every other word, but you get the gist of it. There seem to be some rules about which things go where, and which things rhyme with other bits and whatever. And while you can appreciate it, it's very, very hard to write. So I think it fits assembly pretty well, assembly language. And I'm hoping to sort of show enough of it today so that you can have that appreciation too. Most of my talks up until now have been very Intel-centric, so I'm trying to sort of rectify that now. The three major vendors I'm going to be talking about today are Intel, ARM, and RISC-V. RISC-V. I never know how to say that. Can someone, is it RISC-V? It is RISC-V. Good, OK. I should have checked that before I was on stage, eh? So this is what you see on Compiler Explorer when you fire it up for the first time. So I'm sure you've all seen the assembly output that this generates. But we're going to look at each of them in turn and kind of go a little bit of an overview about what's going on, and then I'll give you some hints about how to read it. Then we'll look at some Compiler Explorer stuff, and then we'll see where we go from there. So the first thing is, this is what that square function looks like in each of those ISAs. For the Intel one, I'm going to be showing the Linux version. Windows is slightly different, and I will talk about that in a minute. So first of all, a point of sort of clarity here. And I've done this myself many times, possibly even at this conference. There is a difference between machine code and assembly code, or assembly language. Machine code is the numbers, so the OF, AF, FF, and all that kind of stuff there. That is the byte sequence in memory that the CPU is going to read, that it interprets as the instructions that the CPU is going to run. And then on the right-hand side is the assembly code, which is the human-readable version of that code. So there is a one-to-one mapping, usually, with some caveats, between the two. That is, the machine code can be disassembled into the assembly code, and you assemble the assembly code to get the machine code. Now, obviously, we lose things like comments, and we lose things like expressions and stuff like that, but that's how the flow goes. So just to look at the Intel one for a starting point, the first thing we're going to do is, well, this square function, it receives a number, it squares it, and it returns it. CPUs have registers. Registers are like global variables that are very limited in number, and each processor and operating system have a different rule about which register means what and what you can do with those registers in order for everything to interoperate. This is the dreaded ABI, or at least the beginnings of the ABI. There's a lot more to it. On Intel, EDI, we'll talk about what that means in a second, is where the input value is coming in. And that first instruction, IMUL EDI, says, take EDI, multiply it with EDI, and then store the result back in EDI. This is a peculiarity of x86. Almost all of the instructions take only two arguments, two parameters, and the left-hand parameter is both a source and a destination. So it's sort of a destructive operation. It's like value times equals value, which hopefully, I guess you could just about see. The problem is, though, on the System 5 ABI that Linux uses, the rules about which register means what, the result has to go in the EAX register. So although we could square it in place, we now have to move it to where we wanted it to go, which is what this mov instruction is doing. Then we return, and we go back to whoever called us. And whatever value they put in the EDI register is now squared and in the EAX register, as they would expect it. For ARM, it's a lot simpler. One thing you'll notice is that for ARM, both of the instructions are exactly 4 bytes long, which is incredibly convenient. Intel, every instruction is slightly different length. It's very, very painful to deal with. Also with ARM, the W register is both the first parameter and the expected output. So we get this rather nice mul W0, 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 which is retval equals value times value. And it's a pretty similar story on the RISC-V. So far, so good. Let's talk a little bit about how the other operations, about what the other operations might look like. So I've sort of waved my hands and just sort of said mul, and I think you all probably guessed that I mean multiply. There are many different kinds of operations, and they may take 0 parameters, 1, 2, 3, even 4 in some cases. Sometimes there are some instructions like the reps.dosb you can see up there, which actually have implicit parameters. They just use only particular registers, which is really confusing. Intel is the worst culprit for this kind of thing because it's sort of organically grown since the 1970s, and they've sort of glommed on new things on top of the old things and kept backwards compatibility all the way. Does this sound familiar to anyone? Sorry. ARM, on the other hand, was sort of a clean room implementation, is a lot more orthogonal, as is RISC-V here, so we're in good shape. Let's talk a little bit about the kinds of operations, the kinds of parameters and arguments that we can have. Intel has some very complicated memory-related things, which I've got other talks that you can look into, but for today, we're just going to talk about the registers. So each register has a different name depending on what size you're talking about. So there is effectively one sort of A register, which is sort of the accumulator. It's the default destination for a lot of implied instructions. And if you could trace it all the way back to the 8080, that was in fact just one of the few registers that we had. It was the A register back in the 8-bit days, the accumulator. But when you say racks, you're talking about a 64-bit value. When you say EAX, you're still talking about the same value. You're just looking at the bottom 32 bits of it. AX is the bottom 16 bits, AH and AL then are 8 bits sort of near the bottom. So as you're reading through the code, the type information from C may cause it to look at different names of the same register. So for example, a routine that takes a 64-bit value and then returns a 32-bit value, you'll see it use racks when it's doing calculations on that input value, but it'll probably move it into EAX to say, I only want the 32 bits. There are some other weirdly named registers here. They have unhelpful names like racks, RCX, RDX, RSP, RBP, and all that kind of stuff. And then thankfully, when AMD increased the number of registers when they went from 32-bit to 64-bit, they decided to call these 8 new registers that they were going to give it R8 through R15, which is just a whole lot easier to remember. We also have multimedia registers and things, but we won't have time to talk about those today. So I talked about the ABI. The bit that I care about the most when I'm staring at compiler explorer output is which register are the parameters to my function in. And so I'm primarily concerned with Linux. I'm used to seeing RDI, RSI, RDX, and so on. These are the first 6 parameters that are passed to any function. Integer parameters, floating point gets a little bit more complicated. But by and large, it's kind of a cool thing that we can get 6 registers. Any more than 6 gets pushed onto the stack, and then we start looking on the stack for those remaining extra arguments, or if you use variarg and that kind of stuff. The output goes in racks, as I said before. For Windows users, we've got 4 parameters before you run out and start spitting onto the stack, and they're in different registers. And this sometimes has some API design consequences, which we'll kind of hint at as we go. But this is what Intel looks like. The ARM is a lot simpler. We've just got X0 through X30. And then if you want to look at the 32-bit version of it, you look at W0 through W30. And if you want to look at 16-bit, you just AND it with FFFF and so on. Those registers have pretty straightforward mappings. I think we already saw this, that like the result goes in X0, first parameter is in X0, and then up through X0 through X7. When you've got 30 registers, you can afford to pass so many more parameters. This is the 64-bit version as well. I know I'm looking in the front row at people who would have used 32-bit ARM and who are going, what? RISC-V has one more register appears, and you think it would be straightforward, but you'll never actually see X0 through X31. The compiler and disassembler rename all of the registers and give them these funny names, which seems confusing to have to remember, but each of the names is actually the meaning of that register. So the T registers are all temporary variables. You can do whatever you like with those. And if you call a function, you have to expect that that function has corrupted those T registers. The S registers you have to store and save and make sure you put them back when you return to them. Arguments go in the A registers and so on. And then there's some stack pointers and frame pointers and other nonsense. Now that's a lot of information, I know. And I can never remember this stuff. So it's excuse me, so as some people who in this room know, I usually have a post-it note stuck on the bottom left-hand corner of my monitor, reminding me which register has things in which slot. Oh, and something I forgot to say as well, that these are like the low-level parameters to functions. So if we go back to the Intel one, where are we there? We might not think about parameters being passed like the this pointer, but it has to be passed somewhere. So if you're calling a member function, your this pointer will be in RDI in Linux, and then the first real parameter that you passed in will be RSI, and so on. And then even more complicated, if you're doing like some return value optimization, if the compiler has decided that it's going to initialize a structure in the parent call frame, it will often put another implicit parameter, which is like, I would like you to put the results of your function directly here, please. So you have to be a bit careful, but by and large, if you're looking at simple functions like my squaring example, you know where things are going to be. But if you can't remember, where are we? Yes, one more. Oh, one less. There is now a blatant plug for the Compiler Explorer ABI mug, available now in all shop.compilerexplorer.coms near you. All profits support Compiler Explorer. On one side it has the logo, on the other side it has the ABI, at least a simplified version of it, as much as I can get in. I used to have a lot more detail on it, but my old man eyes can't read them, and this is primarily for me. So if you buy some, that would be great too. Okay, we've done enough chatting. Let me see how well I can use the screen down there. Oops, don't wobble things. So here's a little example bit of code. I know I usually show something a bit more straightforward than this, but hopefully you can get a gist of what we're doing here. I'm checking to see whether or not some kind of string view I've been given is a valid identifier. And my identifiers are 16 characters long, and they must only contain 0 through 9, A through F. And there is a million ways to do it, and almost all of them are better than what I'm doing here, but it suits my purposes. So let's load this up in Compiler Explorer and hope that it works, because the Wi-Fi here has been a little bit temperamental, and that is not quite the scale I was hoping for. Let me see, okay. All right. I think there's conflicts between my old man, make everything twice as big for my poor eyesight, and whatever's happening with this screen here. But anyway, I think that's mostly readable by everyone here. So we can see, and most of you know these things already, but I'll just do a very super quick thing. As I'm mousing over the C++ code, you can see that on the right-hand side, the assembly code corresponding to that is highlighting. And actually, the same is in reverse here as I go over these. Like, in fact, some of these, in those, even the line, which, none of these apparently, but yeah. So there's the false going in, and so on and so forth. No, so at the moment, we're using GCC 15.2, and we've got just 01 on. 00 tends to be so very literal that everything you've asked it to do, it just does as dumbly as possible, which is great for debugging, but sometimes it's even hard just to reason about because you can't see the wood for the trees. So what we can see immediately, this yellow segment over here corresponds to the yellow segment on the left-hand side, which is checking to see if the size is 16. Now, we've got one argument to this function, and I know that you can't quite see it at the moment, so I'm just going to scroll it so you can see. We're taking a string view. What is a string view? Silent. Pointer and a size, exactly. So a string view is a struct that has two members. The ABI actually allows the compiler to pass those in consecutive registers. So although you would think maybe passing a structure means it has to be passed by reference in some way or whatever, in this instance it's being passed by value in the first two registers of the ABI. So the first thing we're doing over here is we're comparing our DI, which is the second, or no, the first one. Oh gosh, you see, this is why I need a mug. And unfortunately, the mugs that I have on display here for good questions are the old ones, OG ones, that don't have the ABI on them, so I can't cheat. But anyway, we're comparing one of the registers that contains the length of 16, and if it is equal to 16, we go on to do some more complicated stuff. Otherwise, we return. And if we've returned, we've put the value 0 into EAX, which is to say we've put the false value there. So that is our if size is not equal to 16, return false. Great, fantastic. And then we scroll down and scroll down and scroll down, and then we're into a little area where there's no color highlighting. And this is because we've inlined several of the functions that the STL has provided for us, or rather the compiler has done. And then we've kind of, we don't try and track it back to the STL because we're not showing you the STL code in our left view, so it just unfortunately shows white. But I don't know about you, I was sort of somewhat surprised to see a call to memture in the middle of that, because I'm doing find first not of. And I'd never really stopped to think about how that might be implemented, but we can see here. But before I go on to that, I'm just going to show you what other things happen when we start fiddling around with O1. This is quite difficult to do. O2. So with O2, it's slightly less code, but we've basically got the same structure here. And we've got this sort of check at the beginning, a few other bits and pieces, and then some complicated stuff involving memture. And then the things that my eyes are drawn to immediately when I'm looking at bits of code are loops. And so what I'm looking for is a label where there is a jump back to it later on. So this L4 and this JNE L4 forms a loop body. And so for some of the things that I would do where I'm looking for vectorization and stuff, I think anyone who was at my Compiler Explorer talk, that is what I look for to sort of see where the atom of the inner loop is. and then you can just see how fast it's moving the pointers forward to get an idea about how many elements it's doing at once. Now, here we're not doing that. In fact, we're just calling memture multiple times. So I'm a bit confused about what it's doing here, but nevertheless, we could sit down and work it all out, I'm sure. O3, do we get anything better? Well, O3, what seems to have happened here is we no longer have a loop, and what we have instead is a massive copy of that memture over and over and over and over again. And so what it's actually doing behind the scenes here is for each of the input characters, and we know that there are 16 because we've just checked there are 16, we're saying, can we find this character anywhere inside the 0 through 9 A to F? And if we can't, it must be a character that is not in that set, in which case we know that we failed the test and we say that was an invalid character and we return. So that's kind of cool. But this is a great example of like using Compiler Explorer to see the difference between O2 and O3. I don't know if just looping 16 times is just fine, because we're calling memture in the middle of it anyway, versus unrolling it and potentially blowing out my instruction cache. I don't know. Let's have a quick look at what Clang does, though. So let's go over to this and type Clang x86 trunk, enter, and hope that we've got enough internet access, or I've got it in my cache. Hooray. Clang largely has done something quite clever, in fact. That is not what it was doing before. Oh, I hate it when it changes. I'm sure it was doing something different. What have I done here? Oh, how peculiar. This was not in the script. Let me, oh no, this is live debugging. What could go wrong? Let me tell it it's running on a Skylake. That might help. No, it didn't help at all. I'm really confused. Earlier, Clang, which absolutely loves to unroll everything, was unrolling everything. And in fact, I know what's probably happened. You know what this says? This says, what version of Clang am I running? Trunk. What happens with trunk? Yeah. I tell people off for doing this. 21, x86, what are we on nowadays? Yeah, that'll do. All right, let's see if I can recover what I was supposed to happen. Yeah, there we go. Right, exactly as I was planning. So Clang absolutely adores this kind of trick here. It's quite a different look to it. And there's all these complicated looking instructions. There's no memture in here. It's sort of inlined it and done something clever with it. And frankly, I don't know what's going on anymore. And there's sort of this strange number over here, which if I mouse over, Compiler Explorer tells me is sort of what looks suspicious to me, suspiciously like a bit mask to me, but I can't really see what's going on. But, you know, we can play around with settings, we can learn about what's going on, and hopefully with a bit of the things that I've been talking about, you get some gist about where you'd start looking. And in fact, you know, as you mouse over this BT instruction, which I'd never seen before, what does it say? Nothing, because nothing ever works in a live demo. Let's try it again. There we are. Selects the bit in a bit strings. I don't. So hopefully you can see that, like, you can get a gist of what's going on, even if we can't see exactly what every single instruction is doing. We've got the idea about what's going on. I can see how many loops there are, whether there are loops, whether there are calls out to other functions that I was not expecting. But a new feature that we've just added, or will just add, is this. Because everything else has involved AI, right? So what we've got here, and I'm just going to zoom in a little bit over here, because one thing my slide thing doesn't let me do is pre-game the size, is we can submit the code and the assembly output to an LLM and say, can you help me understand what's going on here? And with all the very many caveats that that has, and with full consent, and only with full consent every time, we'll do this. And I should have clicked this before, because it doesn't have to take a little while when, like, the only person in the world that's using it is me. Because something lambdas, something AWS, so talk amongst yourselves. So, and again, so this has to be taken with a pinch of salt. And this is a beta feature, and unlike any other feature I have in Compiler Explorer, this might go if it becomes more expensive or it proves itself to be very misleading. I only want to have this to be a net benefit. But so far, with all the things I've thrown at it, it's done pretty well, at least as well as most people I overhear trying to explain assembly to each other. But I'm sure it's a lot more confident sounding than they are, so that's one thing to bear in mind. So it tells you, like, this is what the registers are. It says, it annotates the assembly, it gives us some idea. It says the compiler uses a clever bit manipulation technique to validate characters, and it actually explains the bit test, because what has happened is it's packed in one bit for is this okay or not into a 64-bit value, and then it shifts down the ASCII value, and it looks up, is that bit set or clear? And so that's a clever little trick that it's doing. So anyway, that's Claude Explain. It's a new feature, and in a few seconds' time, actually, if I go and press enter on this dialog over here, it will be unleashed upon the masses, or at least it hopefully will be. So, oh, I forgot I was going to Alt-Tab over to this, but that's me actually deploying Compiler Explorer in the background. What could possibly go wrong? But again, AI is shown to be an interesting technology and one that's certainly pervasive, and there's been a lot of discussions about it, and people have opinions about it. And I just want to add, before you kind of start throwing absolutely everything at this, a cautionary tale. And that cautionary tale is, don't always trust the computer. Please hold. There we are. So I was visiting my parents earlier in the year, and it's the village that I grew up in, a slightly different place from where you saw the photograph from earlier. And I was just coming back with some shopping in the car, and the normal road that I go down, a lorry had shed its load. Sorry, a truck had dropped its cargo. I don't know how to translate these things. But anyway, a road was closed off, and a main road that I normally go down was closed off. And so I thought, well, I know, I'll just go past the entrance to the road, I'll drive down to the next village, I'll do a left, I'll turn around again, and I'll come back round the other side. No problem at all. Now, bear in mind, I lived in this place for 15 years, and I delivered newspapers to every house around me for 6 or 7 years of those. So I know the area pretty well. As I was driving down the road to the next village, the sat-nav, please wait, get the focus in the right window. The sat-nav, there we are, said, hey, if you take this left road, although it's a private road, you can get down the end of it and then you can get out on the other side, and that'll save a whole 20 minutes of driving. I thought, fantastic. I had no idea you could drive down that road. You can't drive down that road. It may not be that obvious, but that car is wedged in tight down a bridle path. So I had to wait for about 4 or 5 hours while dog walkers kept coming past me going, are you all right? I'm like, I'm fine. And they said, like, don't worry, the delivery vans get stuck down here all the time. And I'm like, well, that doesn't really help me because there's no way I can reverse out of here now. So it took 4 or 5 hours to get out, and a lot of pride. But amazingly, the rental place took it back without even saying anything. So did all right there. I did the honorable thing, and I went to OpenStreetMap afterwards, and I fixed the damn thing on their plans to say, no, you can't drive a car down this. And even if you could get past this bit, it was closed off at the far end. So it was a nightmare, but yeah. So don't trust technology blindly. Even though it looks confident and sounds plausible, check it. Oh, I got 50 minutes left. This is awkward. I suppose we could go back to the definition of assembly. What other things might be valid in C++? A set of pieces that work together. What does that sound like? Anyone? Programs? No? Anything? Assembly? I mean, obviously, those fit together. Production? Yeah? No? This is a terrible plan. I was thinking lots of audience interaction, but I can't hear half of you. But anyway, what I think of when I think of a set of pieces that work together, I think about all the libraries that we use and how they can be made to fit together, or they do fit together well. And so I started doing some digging. I thought, well, what is the uber C++ library? What do you think of as like the best example of a C++ library? Boost, yeah. All right, what else? Anything else? Abseil. What about one that everyone can use? STL. The STL. Thank you. We got there. It's one of those things where I'm asking you questions, you have to say the right answer, okay? I should have seeded this before I came out. The STL. Now, I didn't know this, but John Kalb did an excellent presentation on Stepanov earlier in the week, and I went to it, and I learned a bunch of things, and I was like, oh, damn, I've got slides for this, so I had to hurriedly correct a few. But the STL, as we all know, is a library that was started in the early 80s, late 70s, early 80s, by Alexander Stepanov, and it was his idea about trying to get generic algorithms, that is, algorithms that don't have to explain what types are involved, or what objects or what functions are needed. Just like, if I'm going to write a sort algorithm, I want to write a sort algorithm for all time and then be done with it. rather interestingly, when I learned this, when I actually started looking into the programming more formally, as opposed to just reading the random books I could find and magazines I could find, I got a copy of Knuth's books, and Knuth also kind of goes over all these algorithm things. And Knuth's approach to this was, I'm going to design my own really fancy assembly code, and then I'm going to implement all my algorithms in that. And that's a very different thing from what Stepanov is doing here, by saying, no, I'm just going to live in a very generic world. So the first version of this generic library looked like this. What language is this, anybody? Oh, I've flummoxed you. Mutterings. No one's confidently calling out. That's fine. I would not expect anybody to know this. This is Tecton, which is Stepanov's own language that he invented in order to explain these generic concepts in his first paper in 1981. So he was at GE at this time, and he was sort of trying to find his feet about how to express the things that he thought were important. So obviously, after this, what language did he go to? C++, I'm hearing muttering. You know that's not the right answer, don't you? Otherwise, I wouldn't be asking it. It was not Ada. It was Scheme, actually. So this is what the accumulate function is in Scheme. So this is a bit later on. He moved on to Scheme. Then he went to Ada, whoever shouted that out. Ada is, in fact, available on Compiler Explorer, so you can go and play with some of these things. The example paper that I found of his did not have the implementation for this particular function here, unfortunately. I couldn't find one implementation that was common in all 4 places, because obviously after this, after he'd found Ada, and he moved on to another language, which is one you probably know of. But the interesting thing about Ada is that Ada has explicit instantiation of like generic functions. You have to tell it ahead of time what functions you want and what types you want them to have. And Stepanov thought this was a good thing. And in fact, when he finally decided to move over to using C++, the early C++, we're in like the early 90s, late 80s, early 90s now, he was arguing with Bjarne and said, no, I think that they should be explicit. And Bjarne's like, no, implicit is the right way to do this. And later on, Stepanov said it was absolutely critical that they were implicit. The SDL could not have been written without Bjarne's insight there and instinct. So Stepanov is a genius, but doesn't get everything right. So by this point, so we're in the early 90s, C++ was on the brink of sort of being standardized. And hang on, let me check your notes. Yeah, the beginning of January 1994, as the C++ standardization process was going, Stepanov had his STL and he was sort of experimenting with it, but it wasn't meant to be part of C++. But Andrew Koenig emailed him and said, is there any chance that you could make a proposal for this to be standardized? We think it's a good idea. And Stepanov said, well, when? And he said, well, the 24th is when we need to make a decision. And he's like, it's the 20 days? Are you crazy? Literal quotes there, as opposed to the general thing. But so Stepanov and his colleague Meng Li worked 80-hour weeks to rewrite the whole thing for the proposal, finding tons of issues, fixing them, and write the paper that to this day is still the largest proposal that the C++ committee has ever accepted. It was voted in with an 80% yes. So either standards were lower then, or he did an amazing job. What an amazing sort of start to this. So Stepanov calls the STL the Stepanov and Li library. He's retired now. But for me, the STL set the tone of C++. That is kind of what I think of when I think of what C++ libraries can look like. The STL is there as a sort of shining example, and loads of things have been built around the really clever concepts like iterators and the complexity time guarantees that we get from the STL. Now, a note on nomenclature here. I say the STL, I'm sure we all do, when we mean the standard library. They are different things. The standard library contains some of the things that were in Stepanov's STL, but it has many other things too. And incidentally, the STL carried on being developed when Stepanov moved over to HP, and I think some of us probably saw the SGI, yeah, the SGI implementation. There have been many implementations of that over the years, and some have included things, like hash maps and things that the standard library did not have. So the standard library is more than the STL. It contains all of these kinds of things. What do all of these libraries, or the headers, have in common? It's gone quiet. Anyone? So each of these started life in was either lifted wholesale or heavily inspired by the Boost project. So a whole bunch of what we think of that's now part of the language started out as a standalone library in Boost. Boost is about as old as the C++ library is. It was released first officially in 1999, and it's kind of a proving, or it was a proving ground for high-quality libraries to sort of show industry experience and gain ideas before it could potentially be taken for standardization, as many of those headers you just saw were. Not everything in Boost is going to be standardized or should be standardized necessarily. So we've got things like Boost Spirit for parser, combinators, Python, compute, Windows API type stuff. That doesn't sound like the thing that should be in a standard library, but it's a great place to go and look and find good quality code. And it's certainly been a source of excellent libraries for standardization. So in 2020, one of the founders of the Boost org sadly passed away, Beeman Dawes, and sort of in his honor, a new project was started in 2024, or at least it was announced in 2024 by David Sankel. The Beeman project is sort of a cousin of the Boost project. Many of the same people, or the original people, are involved with it. And it sort of has a slightly different take about how to get things into the standard or how to produce libraries. All of the libraries in the Beeman project are slated or intended for standardization. It's like a fast-track, relatively low overhead process by which a library is submitted. There's a lot of support around merging and fiddling with the standard library, which is not a straightforward thing to do, and then to sort of bring it forth with a paper for standardization. So it's hopefully going to be a conveyor belt for getting new features in, have them battle tested, and then merged into the standard as and when it's ready. We've got things already like the optional extensions, which I saw Steve Downey gave a talk on earlier. Like, thank heavens, we finally have optional tref. I mean, I've been using null pointers forever, but it just makes me feel dirty every time I use a null to mean there's not something here. It doesn't seem right, does it? So I'm looking forward to that. There are scopes and tasks and then any view, things like that. There are about, I think, 13 different projects within the Beeman project, including an exemplar, which is like a showing how it should be done, which is just the identity, which is quite cool. And again, this is sort of complementary to Boost. It's not in competition with it. And my clicker. Of course, Boost and Beeman are not the only sources of libraries that are high quality and have made it into the standard. We're absolutely blessed to have people who are prepared to go through the gauntlet of taking their personal library and then go working through the wording with other people and finally getting it into the standard. So here we've got Barry Revzin's ranges, Viktor Zverevich's format, Howard Hinnert's date library, which is a godsend, span and MD span. Both of these last two libraries here are absolutely, well, span is ubiquitous in all of my code these days. I haven't had an opportunity to use MD span yet, but it's kind of interesting because a huge consortium of mostly GPU vendors and large HPC installations were interested in it. So some cool things there. So it's not just massive projects with multiple sub-projects that are getting into the standard. Individuals can get their code in on small consortium. Well, I guess that's a very large consortium, actually, now I think about it, can get into the standard. And obviously, there are modes of libraries that don't make it into the standard or never intended to be in the standard. They're just standalone, high-quality libraries that we can reach out and get. You mentioned some of them earlier when I said about this. Someone said Abseil, I heard, and we've got some great examples here of some of the really high-quality C++ code that's available to us. So, C++, some assembly required. I think a set of pieces that work together, we can check that one off. That fits. What's next? The process of putting together a set of pieces. What do you think of? Linker. Yes. What else? Packaging. Yes. What else? I can't hear that. I keep asking. No. Anyway, well, I'm sorry. I'm asking you questions and I'm unable to hear the responses. But, I'm just trying to keep you awake. It's Friday afternoon. And I'm in between you and the bar, and I know that I've got 39 more minutes of your time, and I'm going to keep you awake. So yeah, I think of all of those things. The putting together C++ code requires a lot more than just C++. It requires, well, first of all, I need to get my code written. And we all know that the best compilers. Oh, damn, I've got the wrong slide. I was looking at the next slide. Ugh. We all know that we have some great compilers. There we are. I'll try and save it. We've got GCC, Clang, Microsoft. There is EDG. There's quite a lot of compilers, and you can ask me how I know that. There are a lot of compilers, but they are high quality, and some of them are community maintained, and we're very lucky to have them. We've come a long way since the original C++ compiler, which was essentially a transpiler that Bjarne wrote that took C++ code and turned it into C code that you could then feed into a regular C compiler, which incidentally was my first C++ compiler, was actually a C front-based compiler. Who here has actually suffered through that? Oh, there's a few sad hands being raised up here, yeah. It certainly teaches you what's going on under the hood, right? If you look at what a virtual function is doing and then you look at what the C code is generated, it's kind of cool. But anyway, we don't have to worry about that anymore because everything can compile C++. And now we get on to the best editor. I might as well ask spaces or tabs. Okay, hands. Spaces. Oh, that's quite a lot. Tabs. Oh, that's far. Oh, I was thinking that would be split 50-50. Wow. Okay, that ruins my joke. But I'm going to say it anyway because nothing's going to stop that. But I like to use a space and a tab so that everyone's unhappy. There we go. All right. But obviously we've got VI, we've got Vim or whatever you want to call it. I know there's a difference. VI and Vim. Oh gosh. All of these cool text-based editors. And then obviously if you like something a little bit more bells and whistles included, we've got all these IDEs. My favorite is CLion down there, but there are a lot other editors that are available. And of course, that means that your C++ editing experience can start with something that looks like this, or it might be something that looks more like this, or Visual Studio Code starting to get a bit more featureful, although I know you can put hateful comments in there. I know you can trick out VI and Emacs. I know you can do it on the language server protocol or whatever, but I'm lazy and I just want the IDE to do it for me. So my IDE, again, is like this one normally. Although increasingly, my IDE looks like this with me trying to say, what the hell is my code? Can you explain this code to me? I only wrote it last week, but I can't remember. Some dark business there about interrupt handlers, well, whatever. So we have a rich way of interacting with and editing our code. We have a ton of ways of building our code. Right? Although we have this compiler, we've got the source code, we need to actually compile it, and it's not trivial, as we've discovered. And anyone who's spoken to me about modules and tried to explain to me how it's not that hard to get it working can definitely relate to this. I learned about Pixie while I was here at this conference, so I had to update these slides. So, come to conferences. It's great to learn new things. The build systems are as diverse as we are as developers, right? It's refreshing to go to other languages where the build system sort of comes with the compiler. But the diversity of things that we do with our build systems sometimes means that the flexibility we get of rolling our own just gives us that much more, flexibility. Sorry, I've gone around in a circle with that. But what I was sort of trying to say is, I've worked with some of the other languages in the last sort of few months, and while it's certainly useful to get off the ground, it's a bit like a framework. Sometimes a framework, if it's the right fit for your job, it's helping you along. You just need to specialize a few bits here and there. And then when you get to something you can't do in the framework, you're suddenly swimming upstream against the framework, and then that's harder. And with some of these more packaged build systems that come with other languages, that you find you want to do something and you can't. Where we don't have that problem. We probably have the reverse problem, which is that you've got too many things, you don't know what's going on. Anyway, we have a lot of build systems. We also have a lot of ways of getting our code that we didn't write. So we've got this wonderful set of libraries, but how the heck do we even get them down? We range from tarballs to Git submodules, although that comes with its own sharp edges. VC Package and Conan are doing sterling jobs trying to make sense of this whole world and make it as easy as possible. And then, thanks to Jason, I learned about CPM, which is like a CMake-based package manager. And so I can't really stand up here and pretend that it's all milk and honey when it comes to putting down packages. We do have choices. We can get it down. It can be difficult, but we've got them. So we also need all those other bits, the bits between the bits that glue things together, the bits that check our code is OK, the bits that give us the tools that allow us to introspect our code and generate code off of it. libclang, for example, or some of the other linters here. But obviously the theme of this conference has very much been reflection is coming and we should use it. So some of these will be fantastic to be able to phrase natively in C++, and I'm really looking forward to doing that. In fact, that's the thing I'm most excited about, is I've got some ideas about my emulators, and I'm going to go home and start doing reflection-based stuff, so very cool. So those are all the different things that help us assemble or contribute to the process of assembling C++ programs. But they're not the most important thing. The most important thing when assembling a C++ program is us, the humans. I've been maintaining Compiler Explorer now, which is not a C++ project per se, which has its own problems, for like 14 years. And I've learned very slowly how hard it is to run a team of volunteers when you don't concentrate on the people, because it's the people that make the changes. And so if your project is awkward to build, if your project is awkward to find and download, if your project has, make sure you sudo apt install these 400 global packages, and then they're not compatible with your computer, then you're not helping yourself because no one else can come in and help you. Obviously, that's the open source mindset here, but equally well, if you're in a company where you've got access to other teams' code, if you can make that code as easy as git clone make or equivalent, then suddenly you'll find people will be incentivized to fix things in your code base. They're like, oh, we found this bug, and we fixed it because it was really easy to get into your code, to build it, to make a change, to send you a PR. The documentation was there. It's great. Think about the humans. It's a really important part of what we do, and I know we like to pretend that it isn't, and like just put our fingers on the keyboard and all, but it is important. It's also useful because if your project is easy to jump in and out of, if it's open source, you are incentivizing people to drop in, make a change, and then maybe leave and not come back. But if you are interested in AI agents, you're giving them a leg up if you're giving them a nice, sane environment that is relatively good to understand without having to explain tons and tons of background. So there's that too. The process of putting together a set of pieces, I think so. I think that kind of assembly is important for C++ too. Ooh. What's next? A legislative body. What could I possibly mean? How convenient. That joke is for one person in this room. So, the C++ committee, or, to give it its magic name, WG21. So if you want to let people know that you know your stuff when it comes to C++, you don't say the C++ committee, you say WG21. Or at least that's what I've learned to say. So I thought, what is this WG21 that everyone speaks of? I kept getting it wrong, actually. I kept saying WG22, which exposes me as a fraud. Well, it turns out that when one international standard organization, which is actually not called the International Standards Organization, it's called the International Organization for Standards, because French, when one standards body loves another one very much, this is the International Electrotechnical Commission, they come together and they have a subcommittee? No, a joint technical committee, one, which has the name of the Information Technology Standards Committee. And then obviously the C++ thing, no, there's more. So within that, and there was no logos for this bit, so we just have a wall of text, I'm sorry. So the ISO/IEC JTC1/SC22, which is subcommittee 22 of that, is the snappily named programming languages, their environments and system software interfaces. So surely now we're done. Nope. Within that, we have these working groups, many of which you'll see are gray and blurry because they are no longer with us. They have done their thing. They've changed the world. They've moved on. But the green ones that are left are the ones that are active right now. And you'll see such classics as COBOL, Fortran, Ada, C, Prolog, Linux, programming language vulnerabilities, and of course, C++ down there. Now, I'm told this is not to scale, and that if I were to draw it to scale, you wouldn't see the other ones. It's just C++. Everyone else has got 2 or 3 people, like, no, more than that, a few dozen people, but C++ dwarfs it. I'm also slightly wondering what binding techniques and conformity are. Very sort of strange sounding things, but never mind. All right, so just to recap. We've got the ISO and IEC that come together for the GTC1, which comes together for the SC22, and within that we have WG21, and we're done. Right? Yeah, no. No, within WG21 we have all of these other subcommittees, both from the administrative point of view, from the sort of core and evolution point of view, and these other SGs that we hear so much of. So what do we got? Within the SGs, the study groups, we have all of these. Again, the same mnemonic. The green ones are active and open. The grey ones that are blurry, we've completely finished and we're done with. We never need to look at them again and they're solved, right? Yeah, near enough. Who here is plagued by undefined behavior? I know I'm not. No, all right. That's unkind. That's unkind of my friends, and hopefully you'll take it in with the love that I mean it. But there are lots of them in here, and lots of the people in this room are involved in those, and so I shouldn't speak ill of it, really. And then, so how does your cool idea for what needs to change in C++ make it? And this is probably the slide I'm most nervous about because I didn't get anyone's actual buy-in. I just read the website and tried to do it. So, Guy, you can tell me off when I've got this wrong. So you've got an idea. You write a paper, you send it to the mailing list or the reflector or some other weirdly named thing that I've never quite understood. But it's a mailing list, and it will be routed to the correct study group for discussion. It will sit and percolate in the study group as the experts in that field will give you feedback, and you work on the paper and you revise it, and then at some point it becomes sort of ready for a bigger audience to see how it might fit into the wider C++. If it's a library feature, it goes to LEWG, which is the Library Evolution Working Group. If it's a language feature, it goes to EWG, which is the Evolution Working Group, I think. Haven't got that in my notes. And then it will sit there a bit longer, and when it's ready, it will go from that evolution to the sort of core group that then makes the wording changes to the actual hallowed document that is the standard. And then eventually, assuming everyone's happy with it, it goes to a plenary vote, and everyone gets to vote on whether or not this is okay or not. And then you get your feature in C++ 32, or 35, 38, or something. Those are probably not real years, are they? I've just realized I haven't done the maths very well. So it's a lot of work, and you might ask yourself, what about other languages? How do they do this? So I actually took a quick look, and I wondered how we compare. So Rust has a different philosophy. Rust has a sort of single implementation philosophy. So whereas in C++ we have this document that then all compilers try to stick to, Rust has an implementation, and effectively the Rust source code is the specification, or rather the tests within the Rust source code are the specification, which is a really interesting thing. I mean, it's nice to have an executable test, right? If anything passes it, then it is effectively a valid Rust compiler. That means they can move a little faster because you just update the compiler, you check it in, somebody approves it, and now it's in the next version of Rust, right? That's kind of cool that everyone gets it. There is a leadership council, and there is a sort of process of RFCs, but it's a little lighter weight, at least I'm led to believe. Again, there may be people in this room who will shout me down at the end and tell me how wrong I am about this, but this is my superficial reading of things. Python, for a long time, Guido van Rossum was the benevolent dictator for life, but apparently not for life, just until 2018 when he retired. So he got to call the shots, he got to decide what went into the language and what didn't go into the language. And I think by the end, it was a difficult process. There were disagreements within the community between Guido and some of the people who wanted features, notably things like the walrus operator. And so I think it was probably in everyone's best interest that he took a step back. And now they have a sort of community governance model. They have a steering committee of 5 people. They have their own sort of RFCs called PEPs. And they try and get a release out every year. So it's a little bit lighter weight, but it's not as formal still as the C++ one. JavaScript notionally has a standards body behind it, ECMA, but I hadn't heard of ECMA before it, so I only knew about ECMA because JavaScript is often called ECMAScript in certain places because that's what it's technically called. It's sort of a vendor-run show because each of the individual vendors kind of call the shots, and then between all of them, they make a decision. There is a committee behind it, so there is a process, so don't get me wrong about that, but it's a relatively lightweight process. So while C++ has this complicated and long-winded process, the thing that C++ has is longevity. And while these languages, other languages have been around a bit too, I think there's a lot to be said for that. So it's always better on the other side of the fence. The grass is not always greener. Anyway, that is to say, we should thank all of the people in this blurry picture, because these are the standards committee, many of whom are in this room here, and they work really, really hard. Yes, thank you, yes. The amount of work that goes into it is absolutely phenomenal. I mean, I catch up with some of the people involved, and I just can't believe how much of their life they dedicate to making this language a better place. And obviously the companies that sponsor them and their families who don't mind them disappearing off for a week to Hawaii and then coming back saying, I promise I was just in a hotel room the whole time. I didn't go out at all. So anyway, a legislative body, I think that's part of the assembly of C++. I think so. What's next? A congregation of people in one place for a purpose. What do you think? Yes. You lot, we're here in a room together. Hundreds of us for a common cause, for a single purpose. And so we've had a difficult few years. There was this thing, I don't know, some kind of germ thing a few years back. Don't really remember it now, I've sort of blanked it out. But C++ conferences are doing well. There are 11 major C++ conferences, international ones this year, which, as far as I can tell, is the highest we've ever had. And so you can see the little dip there where our COVID thing hit us, but we've recovered pretty quickly and we're still going up. So it's pretty cool. So come to conferences. I'm sure everyone in this room agrees that it's been a valuable time, and not just because of the content. There's the hallway track, and then there's that sort of bumping into or wandering into talks that perhaps you wouldn't pick off of YouTube. You just kind of hear someone talking, like, oh, that sounds interesting, and you walk in and you see it. And then it's just fantastic to hang around with everyone else who kind of has a common purpose. But it's not the only way you can get involved in a sort of congregation. I bet you, within 100 miles of where you live, there is a meetup, a C++ meetup, because there are 133 of them. At least there were when I checked. And so you will find a local meetup where you can meet similarly minded people and discuss C++, or not other things, anything, but you will have something in common with these people. And it's really quite something to be able to spend time, get to know other people, and have those kind of informal conversations where again, without sharing like trade secrets, but you could at least discuss techniques and things that have worked for you and whatever. It's just nice to have that and be in an informal setting. Now, a meetup can be as simple as going to a pub and sending a message to a bunch of people saying, I have my laptop, I'm at this pub, I'm going to be sat there for 3 hours. If you come and join me, we can talk C++, but otherwise I'm going to sit and have my 1 pint and then I'm going to go home. And I reckon you'll have more than one person join you. Or it could be a big, organized one, like some of these bigger ones on here, where a company generously gives up some space. You get external speakers, they have formal slides like this, they stand up and talk in front of you all for an hour. That's great too. But there are so many other ways of doing it. You can have lightning meetups. You can have just a mingle and chat at a corporate in an environment where as long as you can find some food or something. It's really cool. Our community grows well when we talk to each other, and this is one way. Of course, this is all in-person stuff, and obviously you all are happy with that, but I know there are people who are watching this who are like, I'm not so keen with the humans, at least in person, and we've got a place for them too. If you prefer to meet online, there are loads of places. There is obviously the C++ Slack, by the C++ Alliance. By the C++ Alliance, I've just freaked out the poor sound guy. There are loads of different Discords. These are just 4 of my favorites down here. And Compiler Explorer has a Discord too, and you'd be welcome there. So you can come along and discuss with people. And honestly, the amount of amazing support that new learners and experts get alike on all of these places is fantastic. Now, if we cast the net a little wider, we could sort of argue that some of these websites that we flock to that also allow us to sort of communicate and modify. Unfortunately, this is CPP reference, which at the time of recording is currently read-only, but we're hoping that will come back. But I know there are certain websites associated with me, but you're more likely to find a CPP reference tab open than a Compiler Explorer tab on my machine. This is an amazing resource, and it's community-driven and community-run. So that's fantastic. And then apparently there are websites where you can put code into it and share links and stuff. There are so many more of them. I know, right? So, a congregation of people in one place for a purpose. I think so. I think that definition fits. Now, the astute among you may have noticed that in my definitions list before, I missed one out because it didn't sort of fit, but I think we should talk about it. A drumbeat signal for troops to assemble, military. Ugh. No. Let's call C++ coders and to assemble. This is your time. This is your community. C++ is amazing, not just because of the companies, but because of the people behind the companies, the people who work in open source, the people who run websites, the people who organize things like these conferences. The amount of work that goes into this is phenomenal. I've had a little glimpse into the world, and it is quite something. But the C++ community is all the better for it. It really does take a village. Every one of you here and online can contribute and make C++ better, whether that's starting your own meetup if you don't have one near you, or joining the local meetup, whether it's coming to a conference and meeting like-minded people, whether it's coming to a conference and standing up on stage and looking back at loads of faces looking at you and going, why am I doing this again? Maybe you could open source something. Maybe you can engage with the community that way. Maybe you can actually get involved with the C++ committee. I hear they're looking for people. There's a nodding in the front row. So you can be involved in this. You don't have to be passive. You can get involved. You can make C++ better for you and for everyone else. I think C++ requires some assembly. Thank you very much. And as I have 17 minutes somehow back, I will take questions, comments, concerns, thoughts, and the most interesting among them will win a Compiler Explorer mug or the coveted final pair of Compiler Explorer socks. Well, final pair that have not been opened and worn by me. I don't know if I should charge more for those. Guy Davidson.
Hello, Matt. It's nice to see you.
Lovely to see you. Fancy seeing you here.
I am the convener designate for the committee, just in case.
For the explanation of jokes, which makes them funnier.
Yes, indeed. So this is a comment more than a question.
Oh, dear. Ooh, OK. Please comment, yeah.
Yeah. You described Barry Revson as being the man in charge of ranges. He's the man in charge of reflection.
Oh.
The man in charge of ranges is Eric Niebler.
Oh, my golly, that's awful of me. Yes,
and he gave a closing keynote. He gave a keynote here in 2025, although that was when we were back in Seattle.
Oh,
and I thought I should just correct the record.
Thank you.
Is a thing that all of us on the committee are quite keen on, and it should be corrected. Thank you.
No, thank you very much. I apologize.
Great talk. Really, thank you for outlining.
Sorry, Eric.
All the assembly required.
Yes. Thank you, Guy, and I do appreciate you correcting me there. That's unfortunate. I will apologize. Hello.
Hello. Can you hear me?
I can, perfectly. Thank you.
I have a question that's semi-related to C++. My question is, what is your favorite architecture? And within that architecture, what is your favorite instruction? And why?
Oh, no. These are difficult. Madeline, you're making this hard on me. Darn it. So I think I would have to say my favorite architecture is the ARM, the original ARM 32-bit. Because it was just so beautiful, it was so well designed, it was so orthogonal, even to the point of stupidity. So every single ARM instruction had 4 bits that were the condition code. So every single opcode was conditional. It would either always run, or it would only run if the flags were equal or less than or greater than or whatever. But because they were being so orthogonal, every bit representation had its opposite. So less than or greater or equal. But that also means that if you always run, there's a never run. And so literally every instruction with F as the first 4 bits was a never run instruction, which eventually meant that 1/16 of the entire addressable instructions were nots, which seems like a bit of a waste. But my favorite within that is the test equivalence if equal setting the processor bit, because it sounds like some kind of god. It's TECEC P. So It's a pointless instruction, really, unless you're doing operating system stuff, but it amuses me because it has a funny name.
Yeah, that's valid. Yeah, thank you.
Thank you for the question. Hello.
Well, thanks for the talk. I think that when most people write in C++ nowadays, we're trying to target x86 as an architecture. And I wonder, if you paste some code, for example, in Compiler Explorer, is it worth trying to learn the sorcery that is x86? Is it worth trying to just change it to RISC-V or ARM and risk the chance that maybe it's going to be a little bit different than what would be exported in x86? Or would it be worth now trying to use that AI feature to just interpret what is in the assembly?
Are you asking that because the ARM and the RISC-V are a little bit easier to understand?
Absolutely.
Yes. So that's an interesting question. So I think at lower levels of optimization, yes. The kinds of things that it does at lower levels of optimization are sort of fungible between architectures. You know, like, hey, I eliminated a bunch of code. I inlined a bunch of code. I found constants and propagated them, and I didn't actually have to do that calculation. Those kinds of things. But at 02 and 03, and some things at 01, some of the really architecture-specific things start coming out. Now, they don't always hit, so you're looking at like average code, you don't necessarily see them, but like, my poster child for this is the instruction that can like count how many set bits there are in a number, and like that might not exist in the target instruction on RISC. I mean, I probably certain RISC-Vs do and certain ARM architectures do. So I think it's a bit of a dangerous thing to rely on too much, but I think certainly from getting the gist of the kinds of things that the compiler is doing at like the higher levels of higher, as in like, not high levels of like, as in increasingly more optimal, I mean high level inlining decisions as opposed to low level picking of instructions. I think it could be valid, but yeah, give the AI feature a go. Give us feedback if you discover it doesn't work or it's misleading, and we'll see if we can make it better. But no, thank you for the question. I appreciate it.
Thank you.
Hello on the other side. I'm going to ping pong, even though this is just not really a time order.
Thank you for the nice talk. Do you miss writing assembly?
Not really. So my hobby, my other hobby, I don't know how many hobbies in we are now, is writing like code for these old computers that I love. So I get to write assembly there where it was tractable and fairly easy to understand, and you could keep it all in your head. The Hitachi SH4 instructions that I put up earlier, that's probably about the limit of what I think a normal human can do. Now, that's not to say that there aren't places where writing a large body of assembly is not valuable, right? You still can get a lot out of it. I visited a company not that long ago, and they were like, well, we couldn't convince the compiler not to spill registers in this absolutely hot loop, and so we just hand wrote the whole thing. And then they have a C version or C++ version and the assembly version. They cross-check them and everything. But I wouldn't want to do that, I don't think. That's just too much effort and work. And especially when in this sort of agile world where somebody says, well, can we make 18 of them now? And you're like, oh, it fits perfectly for 16, and now I have to completely rewrite it to make 18 of them fit, or whatever. So I don't miss that. But I do miss the sort of intellectual challenge, but I get enough out of that from my retro stuff.
Thanks.
Thank you for the question. Hello, over here.
Hello. Thank you for the talk. So having had the pleasure of using Bazel for better part of past 7 years, I just wanted to mention that Bazel is also now a package manager, since I didn't see it on the package managers with the Bazel Central Repository.
Oh, cool.
It's also kind of a package manager too.
Oh, fantastic. That's useful to know. I know Bazel has definitely got some interesting spins. I mean, I knew it when it was Blaze, and there were some cool things going on back then, but then, whether it survived the process of coming out of its alma mater or not, I don't know. Hello on this side.
Hello, thanks for a great talk. I thought that I abused ARM assembly in my talk. Apparently I haven't. You went full throttle. Thank you. It was a joy to listen and watch. I've got a question on assembly. I couldn't find any sort of support in Compiler Explorer for a fundamental architecture, which is Donald Knuth's mix, or mmix. Is it coming anytime?
It has been mooted amongst the Compiler Explorer authors, yes. I would like to get it in. It's a question of time and priority. You'll find that there are, if you look hard enough, we do actually allow you to compile to Commodore 64 and to Sega Master System, and then run emulators inside Compiler Explorer. It's kind of Easter egg territory, though. But having mix would be cool, or mmix, as you say, would be cool as well. Are there any compilers that target it, or would you have to assemble everything?
I'm sure there is like an emulator at least.
I'm sure there is too. Yeah. No, we're an open project. We have a very welcoming Discord and hopefully easy to get into code base. If you're interested, do let us know.
I get the message.
Thank you very
so
much. Thank you. Hello.
Thanks for the talk. My question is, in a world where most people can very easily finish university without having seen or worked on C or C++ code, how do you bring new people into this assembly?
That is an excellent question. It's one of the ones that I think about a lot. And honestly, about 20 years ago, 15 years ago, I thought that the unique position that I had been in, you've seen my home setup where, a computer that you have when you're age 8, 9, or 10, you turn it on and all you have to do is, the only thing you can do is type stuff in, and you kind of have to just learn by osmosis what the heck's going on. And so I thought, that's it. There's no more generations left that are going to have this low-level thing. And then many years later at Google, I was finding graduates who were coming in and they were hacking on low-level hardware that they'd found. They were trying to break like the train system's contactless payment system. And I'm like, there's hope. People are still finding it. So what I think is changing is that a generation about my age were exposed to it, and the people who like that kind of thing stuck with it for 40 years and are now on stage talking to you. And then nowadays, the people who still would like that find their own path to it. And so maybe they weren't taught it at university, but if they like that kind of thing, I think they will find it. And there's plenty of content on the YouTubes for people who are interested in that kind of thing. So I'm not too worried about it, actually. I went through a period where I was, and now I think these people will find a way. So I don't know if that fully answers your question, but I think I'm still hopeful for it. I don't know that we have to do anything. I think people will discover the content that interests them.
Thank you.
Thank you. Thank you for the question. All right, we're going to go over here. Hello.
Thanks for the talk. If you had the power, what would be one feature you would add or remove from C++?
Oh, no. This is how to win friends and influence people, isn't it? If I could remove one feature or add, I probably, if we could get rid of the preprocessor, but replace it, so this is adding and removing, finish off the job that we've already started of like making the preprocessor less and less important, and then finally get rid of it entirely, that would be great, I think. So, I don't know, yeah, I'm trying to be diplomatic in my answers over here as well, but thank you for the question, that's very challenging. Hey, Daisy.
Hey, Matt. So you spent a lot of time with agentic coding recently, and you've spent a lot of time designing tools for humans. Compiler Explorer is very much a tool designed for humans, very visual, very much correlates. You know exactly where I'm going with this question.
Designed is a bit strong, but grown, yes.
But you mouse over the line, and then you see the assembly, and you get colors, and you get things highlighted. What does the analog of Compiler Explorer for an agent look like?
That is a really interesting question. So there are MCPs that let you ask questions of Compiler Explorer, but the thing about Compiler Explorer is although its back-end APIs do a good job of returning JSON documents that kind of give you the information you need, it isn't very agent-friendly, and it's usually gigantic. So amongst the developers of Compiler Explorer, we're kind of kicking around some ideas about exposing tools that have sensible agentic kind of output and like allow them to search within things. So we're thinking, it's been kicked around as even earlier today when I went back to my room and I was looking at the chat in the Discord and people are coming up with ideas. So hold that thought, I would say. Hold that thought. And if you could make it so the MC protocol isn't such a cluster to implement on a server, that would be great. I say that advisedly and with love in my heart. I'm sorry. Hello on this side.
Hi, Matt.
Hello.
You've assembled a great assembly talk.
Oh, thank you. Good pun. Yeah.
But I do have a question. So when you see surprising assembly output, how do you usually know whether it's basically like a compiler optimization or UB, undefined behavior, or just maybe the actual target architecture that's being the problem?
Gosh, that is a very difficult question. In some cases, the compiler will emit instructions in the stream where it thinks, I can't possibly get here, so I don't know. So oftentimes, if you fall off the end of a switch statement or in a function that should be returning a value, you might see it puts like a UD2 or equivalent, which is like a trap instruction. So if you see one of those and you think there's any plausible way you could get to it, then that's a sign the compiler said, hey, dragon's here, right? I won't get here. But the honest answer is Google, probably. I just look at the instructions, I look them up, and or look at the compiler explorer app and go, does this make any sense at all? Unfortunately, there is no magic wand to wave and say, oh, is this UB or not UB? Because I think, what do they say about sophisticated magic and civilization and technology? Sophisticated technology is indistinguishable from magic, and I think the same is true of compiler optimizations. And it really is a lot to reason whether or not that was just smart and the compiler's done the right thing, or you've underspecified something and the compiler's done something valid, but will break your code. So sorry, I don't have a good answer for you, but that's how it is, I'm afraid.
That was a great answer. Thank you so much.
Thank you for your question. Hello. Oh, yeah, you might want to bend that down. There we are.
So I'm really excited for the LLM feature in Compiler Explorer. I've been using LLMs to do assembly programming for a very, very long time, and I've been noticing a lot of accuracy problems in the past. So I'm very curious, have you noticed accuracy problems? Are you depending on the raw knowledge of the model, or are you uploading the entire respective spec for the instruction set architecture?
That's a great question and a great observation. We are currently, for cost reasons, using the cheapest version that we can possibly find, and with a relatively small system prompt that doesn't have very much detail in it. That said, I've been pleasantly surprised about how well it does, as long as you coach it enough to say, if you're not 100%, 1,000, 2,000% sure, then don't say this is an optimization. Please don't, So that's going to change as we go through and learn from what people do and send us feedback. But I think probably it's easier to intuit and guesstimate and sort of extrapolate, maybe with a little overconfidence, from an existing assembly program than it is to generate one from scratch, where if you did invent a new instruction, that's just a fatal mistake. So I think I'm cautiously optimistic, but we'll see. Thanks for the question. Hello, April.
Hello, Matt. So you spoke about, hello.
Oh.
Louder than I thought. You spoke a bit about how you think there's still room for it to be valuable for people to write assembly today. Do you have any thoughts about the way that instruction sets are developing? 50 years ago, they were designed to be written by hand. Now it seems like they're more designed to be generated by compilers at the expense of being hand-read or written. Do you think that's worrisome or fine, or do you disagree?
I don't know that I do agree, actually. I don't know that I disagree strongly, but I think the way ISAs has developed, at least the experience that I've had of new instructions coming through and new ideas, they always target a particular demographic of needs, be it hey, and you look at if you open up the Intel manual and you look at the parallel compare maximal difference instruction, you're like, what on earth is this for? It compares all possible 16 combinations with all other 16 possible combinations, finds the maximum difference between them all. And you're like, this is stupid, until you read the spec for motion JPEG, and it's like, well, this is just a motion compensation instruction. Right, so the changes that I'm seeing in the ISAs are usually domain specific, and then humans usually go and write those particular snippets. We may teach a compiler how to do that, but that's incredibly specific. So I don't know that they've changed hugely in the direction of being antagonistic to human writing them, but I don't think so. But I'd be happy to chat more about it later on.
That's a good point. Thank you.
Thank you very much. Okay, we've got 2 more questions, I think. Are we good for 2 more questions? Okay, we'll take yours and then behind you. Lara, hello.
Hi. So, fascinating talk. The assembler that comes with bin tools or your compiler tends not to be the best assembler for human-written assembly. And I've kind of come across a few assemblers, and mostly they ASM with a letter in front, like NASM, TASM, YASM.
Yes.
Do you use any of those? Because a lot of them seem to be not actively maintained. Is there a space for a new for-human assembler?
That's a fascinating question. Quite possibly, yes. I'll be honest, I haven't had to write x86 assembly for a very long time, so
It's not about having to write.
I haven't written x86 assembly for a long time, so yeah. No, it would be interesting to see what a modern take on an assembler would look like. So I'm intrigued with what you might have in mind. We should talk afterwards. So very quickly then, last question behind you. Thank you, Laura.
Hi. Thank you for the talk. Sorry, it's not so much a question, it's kind of a comment based on what you've already said. And I don't know, because not assembly person, obviously, but I do believe the LLM example that you had there, I want to say it got it wrong because it said RSI was the length. I could be wrong. So
yeah, you could. You may. It may well be wrong, actually.
Anyway, I can't resist an opportunity to poke.
No, absolutely no, and you'd be right to.
Grain of salt, if you're going to use that.
No, absolutely, grain of salt with it, and also it's non-deterministic. So if you went again, you might see it, might get it right. So that's interesting. I'll take a look at it. But thank you for the comment. And with that, I think we're done here. So thank you all very much, and I'll hand over to Mr. Kalb. Thank you. Thank you very much. Oh, thank you, John.
Thank you all.